The moon looks peaceful from Earth, but the moment humans try to live there, it becomes a trap. No air, no protection, and one mistake could turn the first lunar city into a graveyard. NASA is not returning to the moon simply to repeat the past. This time, the mission is not just about planting another flag. It is about staying, building, and turning the moon from a place humans visit into a place humans can live. From far away, it looks familiar, bright, silent, almost peaceful. But up close, the moon is not peaceful at all. It has no breathable air, no weather, no thick atmosphere to block radiation, no oceans, forests, or natural protection, and no rescue that can arrive instantly if something goes wrong. The surface is exposed to space every second. Radiation falls directly from the sun. Tiny micrometeorites strike without warning. Temperatures shift between brutal heat and freezing darkness. And the dust may be one of the biggest enemies of all. A permanent lunar city would have to solve every one of these problems, and that is why the first moon city will not look like science fiction. It will not begin with glass domes. It will not begin with shining towers. It will begin with landing pads, power units, habitats, cables, rovers, tools, and survival systems. Because before humans can build a city on the moon, they must first make the moon usable. One of the most important places for that future is the lunar South Pole. Unlike the Apollo landing sites, this region is rough, uneven, dark, and difficult to explore. Some crater rims may receive long periods of sunlight, but nearby, deep shadowed craters may have remained dark for billions of years. Inside those shadows, scientists believe water ice may be trapped. On the moon, water ice could become one of the most valuable resources in space. It can support astronauts. It can be processed into oxygen. And one day, it may help produce fuel for spacecraft. This is why the South Pole matters so much. It is not just a landing site. It could become the foundation of a future lunar economy. But before that future begins, NASA must deal with one of the moon's most dangerous problems: dust. Lunar dust is extremely fine, sharp, and abrasive. It can cling to equipment, scratch surfaces, damage seals, and slowly wear down machines and spacesuits. During the Apollo missions, astronauts already learned how difficult this dust could be. It stuck to suits, it entered equipment, and it made even simple movement more complicated. When a spacecraft lands, its engines can blast this dust across the surface at high speed. Around a future base, that cannot happen again and again. So the first step toward a moon city may be building solid ground. Landing pads, roads, work areas. These surfaces could be made by compacting or melting lunar soil, also known as regolith. Regolith is not just dirt. It is the raw material of the moon. Future construction systems may use it to make bricks, tiles, protective walls, and radiation shielding. This matters because launching everything from Earth is expensive. Every kilogram costs energy, and a real lunar city cannot depend only on supplies from home. It must learn to use what is already there. The first habitats may arrive as metal modules or inflatable structures. They would provide air, heat, pressure, and basic living space. But they cannot remain exposed forever. The moon's surface is constantly hit by radiation and tiny particles from space. Covering habitats with layers of regolith could help protect the people inside. From the outside, the first homes may look low and buried, not beautiful, not futuristic, more like protected shelters than a city. But inside, they would contain something extraordinary: breathable air, warmth, water, and life held safely inside walls built on another world. Transportation will be just as important. Pressurized rovers could allow astronauts to travel without wearing spacesuits every moment. These vehicles may become mobile workstations, laboratories, and temporary homes. They could connect habitats to landing zones, carry crews to shadowed craters, and allow exploration far beyond the first base. But every system depends on one thing: power. Without power, life support stops. Water freezes. Solar power will likely play a major role. But the moon has long periods of darkness, and some of the most valuable ice may be hiding where sunlight never reaches. That is why NASA has studied small nuclear fission systems for the lunar surface. A compact reactor could provide steady power even during the lunar night. It could support habitats, charge rovers, operate mining systems, and keep life support running. With reliable power, the base becomes more than a temporary camp. A landing site becomes a work site. A work site becomes an outpost. An outpost becomes a settlement. And over time, that settlement could grow into the first human city beyond Earth. But this will not happen quickly. It will be difficult, expensive, uncertain, and every part of it must survive an environment that does not forgive mistakes. Yet that is exactly why the moon matters. It is close enough to reach, but harsh enough to teach us. It can test the technologies that future explorers may need on Mars. It can become a gateway to deeper space. And it can prove that humans are capable of building beyond the planet that created them. The first city on the moon may not look like science fiction. It may be small, buried, covered in gray dust, surrounded by landing pads, power systems, rovers, cables, machines, and unfinished work. But if it survives, it will represent one of the greatest changes in human history. The moment the moon stops being only a place we visit and becomes the first place we learn to live beyond Earth.